In this video, we'll finish up our discussion of section 14.6 over triple integrals with two more examples. This one is going to be a setup, and I'll give you the answer for you to try to get to. Okay, so we have a surface, right? So our beginning surface. Then I have my other bounds. Okay, so I see an xy equation. I also see this. Remember, this is the xy plane. And then they also want all x's that are greater than 0. Okay, so y equals negative x squared plus 2. Hopefully you recognize that. That is just a parabola flipped over that goes through radical negative radical 2 and positive radical 2. So we have something like that. Y equals 0, right, is this graph here. All right, so this was y equals negative x squared plus 2. And then this one was y equals 0. And then they say also x is greater than or equal to 0. So we're actually talking about just this region right there. So above that region, in 3 space, we're finding the volume that's captured above that. Okay, so we have, z's. We have z equals 0 and that. So that's easy. Let's set up this volume. Volume equals, let's spread these out in case we need them. I always forget to do that and then end up shoving it in there. Z equals 0, that's the xy plane, up through the surface, which was 9 minus x cubed. I then get to determine how I want to define y, or x next. I'm going to do from this point up, that's the easiest. Everything's already in y. So this would tell me that y goes from 0 up to negative x squared plus 2. And then the x, if you're unsure, you would just set the surface, that negative x squared, not the surface, the curve. Negative x squared plus 2 equal to 0, and solve via x squared equals 2, which means x is plus or minus the square root of 2. So we get x equals the negative square root of 2, x equals positive square root of 2, and then we get dz, dy, dx. And then I'm going to give you an answer here in case I'm not going to work it out to that point, but I will give you this answer so you can check yours if you'd like to work it all the way out. The answer I got was 12 radical 2 minus 2 over 3. All right. If you need help with that, please let me know. I have the work. I can send it to you. No big deal. Or I can help you work it out. All you have to do is reach out. All right. One last example here. Problem 7. It says find the volume of a solid bound by the graphs of the equations. Okay, I have z. That's my surface. Then I have a relationship between x and y. That's a line, and then a parabola. So there's my x, y. Let's graph those. So x plus 2 has an intercept of 2, slope of 1. It's good enough for me, so we'll connect those. If that'll correct itself. There we go. So we have that line. This is y equals x plus 2. We also have the parabola that goes through there. 0, 0, 1, 1, 2, 4. So it looks like it's going to intercept right in there. Right, and then they also said the first octant. So there's my first octant. So it's everything that is inside of here. We're going to find the volume over this region, over that region, for the surface, z equals square root of x. Okay, so my volume then. So we're going to do z first. It is that plane. It says first octant, so that tells me z equals 0. Up through z equals the square root of x. Y, now I just determine bottom curve and top curve. Okay, bottom curve is the parabola, so y equals x squared. Top curve is the line, which is x plus 2. And then we just look at our x's. X goes from 0 to 2. Okay, and then we make sure our dz's, dx's, dy's are right. If you work all this out, which I encourage you to do, the answer is 108 over 105 square root of 2. If you can get that or a decimal, then you'll be set there. So these are nothing new. The hardest part is setup. Just get some reps under your belt.